In this video, I'm going to go over what we need to understand about sequences and series for the exam tomorrow. So I've written down the 3 things I expect to be able to do for sequences and series here on the right. We're going to have to use the notation for the sequence to find the terms of that sequence. We're going to have to evaluate that sigma notation, that summation notation we saw, and then we're going to have to deal with application problems. And obviously the application problems are the biggest part. So I'll do 2 quick examples, one for the first 2, and then we'll run into some application questions. So the first example here, I've given you the sequence, the nth term formula, right? And then I could ask you to find, say, the first term, the second term, the 10th term. And this is all about realizing that this notation is very similar to our function notation, and that whatever our subscript is, whatever our a is, we just need to go ahead and replace that in the 2 places where n was in our actual nth term formula. So in this case, no matter what, we're going to take whatever our number is, we'll add 2 to it, and we'll square it, and then we'll divide by itself. So that same format is going to be in every single one of these. And then we're just plugging in whatever we have. So 1, we'll plug in 1 for the first term. Second term, we'll plug in 2. And then the third term, we'll plug in, or the 10th term, we'll plug in 10. And then we'll just go ahead and evaluate what the heck we get out. So here we have 3 squared over 1, which is 9. Here we have 4 squared over 2, which is 16 divided by 2, or 8. And here we have 12 squared over 10, which is 144 divided by 10, which if we want to, we can go ahead and simplify it down to, what is that, 72 over 5? So, or 14.4, whichever we want. So those are our different, how to evaluate the terms using the notation or the nth term from a sequence. So the second example thing we need to be able to do is we need to be able to evaluate the sigma notation. So we could do something like this. We'll use that same sequence. What was that? n plus 2 squared over n. And we could do something like, let's start with n is equal to 2, and let's go up to 5. So what this is telling you is that we need basically that we want to add a sub 2, a sub 3, a sub 4, and a sub 5 together. That's what this tells us. This is our starting point is the 2, our ending point is the 5. So we're going to start with the second term, go all the way up to the 5th term without skipping any terms, and add them together. So then we just need to figure out what those terms are. A sub 2, we found before, that was 8. A sub 3, well, that's going to be 5 squared over 3, which is 25 over 3. 4 is going to be 6 squared over 4, so that's 36 over 4, which is just 9. And 5 will be 7 squared over 5, so 49 over 5. Whatever the heck those add together to, that is our answer. I don't have my calculator with me here in the back of my house, so I'm going to go ahead and just make this quickly. Make these all common denominators. We can add them together. I wouldn't bother with this normally, except for that we're in the rational section, so it's actually not a bad thing to go with. So 8 times 15, what is that, 120 over 15. Then we've got 125 over 15. Then we've got, oh God, my brain, it hurts. It's 90 plus 45 is 135 over 15. And, okay, brain, this was a terrible idea. Looks like 147 over 15. So if we add all those together, I'm so unhappy with myself right now. 2, 7, 8, 2, 5, all over 15. Do not quote me on this one. I should really get out a calculator, but I'm being lazy. I think the majority of what you need to see is this piece, how these 2 pieces work. So for always this summation notation, you should just get out a whole number, a number out at the end. So let's see the application stuff. This is the piece that matters the most for the exam. So I know, Isaac, this is what you cared about seeing. Whoop, whoop. All right, so I'm going to pause the video, write down the questions so that you guys don't have to sit here watching me writing a lot of stuff. Our application question is this. How many poles will there be in a pile of telephone poles if there are 50 in the first layer, 49 in the second, and so on until there are 6 in the top layer? So first thing I'd like to do on these questions is to draw sort of up what's happening. So there are 50 telephone poles in the first layer, right? I could even draw some cute, make them look like poles, right? Anyways, in the next layer, there are 49, one less, all the way up until you get to the last layer where there are 6. All right, so we could obviously figure out the total number of poles. This is how many poles are going to be in the pile. We could obviously figure this out by just brute forcing this 6 plus 7 plus 8 all the way up to the 50, right? That is possible. We will get out our answer and we'll know exactly what it is. But on the test, I say you have to use the formulas. So the first thing you want to do, first question you'd ask yourself is this geometric or is this arithmetic? Right? Are we multiplying by the same amount each time or are we adding the same amount each time? So in this case, if you think of 50 as the first layer, to get to 49, we are subtracting 1. To get to the next layer, we're going to subtract 1 again and again and again. So this is an arithmetic sequence. And even more so than just being arithmetic, we now know the difference is -1, if you want to think of 50 as your bottom row. Now, there's no reason you have to think of 50 as the first row. You can always flip the script, think of 6 as your first row, and adding 1 each time. Either one is completely okay. So I'm going to go with 50 as my first, just because that's, I think, what a lot of people would do. So a lot of students might do. So in this case, the first row has 50, second row has 49, all the way up until some row that we don't know, some nth row where there are 6, right? And the goal is to add all of this crap together. So we want to find that sum. So this automatically tells us that the formula we want to use is the S sub n formula, which tells us add the first one and the last one together and multiply by n over 2. And this is easy at first. We got 50 plus 6, and then we realize we never actually figured out how many rows there are. So we don't have the n yet. But this is where we could actually use the first formula, because we have another formula for arithmetic, right? A sub n is equal to a1 plus n minus 1 times d. And you can barely see the d there, I'm sorry. So we know what the last row has. It has 6. First row is 50. We don't know n, that's the piece we're looking for, but we do know our d is -1. That's how much I added each time. If I thought of 6 as the bottom and 50 as the top in terms of starting. So if we multiply this all out, we get 6 is equal to 50 minus n plus 1. So 6 is equal to 49 minus n. So 43 is equal to n, right? We get a negative on both sides, but those cancel. So apparently, if I had done this all the way down, this n is actually 43. And that means this n here, oops, I can leave that in n, is 43. So now we have what it is that we want to calculate. So whatever the heck 56 times 43 over 2 is, that's what we need. So I have to bring up a calculator because I cannot, you saw how bad doing math in my head was last time. We get 1,204 logs in this whole entire thing. Or poles, whatever you want to call them. So that's sort of how we would use this. This particular question, first step we found out it was arithmetic. Second step is we always want to figure out, are we dealing with S sub n or A sub n? Do we want all of them added together or do I just want its term? And in this case, we actually had to use both. We wanted S sub n, but we had to use the A sub n formula to figure out what our n was to plug into that. So I'll do one more question for you guys. One more application. So I'm going to write it down. I'll come back and I'll give you a chance to try this on your own. Here's our example. I urge you to take a moment, pause the video and try this on your own. See if you can do all the steps. So first thing I like to do is get a bearings for what the heck is going on. So I like to start with my N. So the first time we have this piece of paper before we folded it, the thickness, right, the height is 0.02 inches. If I fold it one time, so now there are 2 layers, the height doubles, right? So now at 0.04. I fold it another time, now there's going to be 4 layers, so it's going to be 0.08. And we go all the way down, and this is where it's always kind of confusing. It says start with one piece and then double it again and again. So I'm going to assume in this case our N is equal to 1 is 1, and that's not folded. So it's always confusing, like does this 10, technically this was folded once, this was folded twice. So should I be going down to the 11th one, because that will be folded 10 times. And on the test, I try to make that less confusing as to whether or not we're starting at 0 or 1. So I'm just going to say for this one, it's 10. So we don't know what this is, but we could obviously brute force this by continuing to double all the way down to 10, right? Now, that's not the way we need to solve these. We need to solve them using the formulas. So first step, geometric or arithmetic. In this case, we can see the pattern here. We're multiplying by 2 each time. We're doubling. So that means we're dealing with a geometric. Second question, do I want to find the sum of all of this, or do I just want to find the last term? So is my goal to add all this stuff together, or to just figure out this last term? And the goal is to just figure out the last term. I don't need to know how tall it was at each point added together. That doesn't make any sense. So we are just looking for A sub n. Once we have those 2 pieces set, all you're doing is going to your formula sheet and grabbing the right, or going to the back page of the test, grabbing the right formula. This formula, A sub 1 times r to the n minus 1. A sub 1 is my first term. We want the 10th term. We're looking for the first term, 0.02, times our r, which was our rate of doubling, right, our ratio, 0.2, into the 10 minus 1. So again, I'll bust out a calculator because I can't do this in my head. 0.02 times 2 to the 9. This is 10.24 inches. So can you imagine taking a piece of paper and folding it until it was 10 inches tall? You cannot actually fold a piece of paper 10 times because this is crazy, right? But very interesting idea that if you could keep folding it, I mean, maybe you had a giant piece of construction paper, you could actually manage this, but otherwise this is unwieldy. So that's our applications. Again, always think this way on the test. And the first thing I would do, no matter what, start here, come up with an idea of what's happening, maybe even work through a brute force to find the right answer, and then fit it in to the formulas.